So now to find the epicenter of the earthquake, we must start off with the location. So I started off with the location as New York. So let's take a look at the seismogram for the earthquake in New York, and let's find a spike in the data, a sudden movement. So let's try to find that sudden movement. So here we see a little variation, and then suddenly a huge spike in the seismogram. So we'll circle that, and we'll mark that as the beginning of the P wave. So this 20 seconds is the beginning of the P wave. So let's mark that as P initial. Now we see little variations, but we're trying to find a huge variation that indicates the S wave. So here we see little variation. Here it's almost steady, almost as if there's been no earthquake at all. Little variation, and then suddenly we see another huge spike, almost like an inverse of the first one. However, as we can see, the S wave continues for about 3 minutes or so, unlike the P wave. So let's mark the beginning of that S wave right over here, and the S wave begins at right about 100 for 15 seconds. So 115 is the beginning of the S wave arrival time. Now that we know the beginning of the P wave and the beginning of the S wave, we can move on to our data table to find all the aspects of the earthquake. So our location is New York City. The P initial we've already marked is right about 20 seconds, so let's write that down. The S initial, we've marked that as well. It's about 115 seconds. Now the lag time is basically the S wave arrival time minus the P wave arrival time. So that would be 115 seconds minus 20 seconds for us, for this specific earthquake. So this would basically be, let's do our little subtraction here. This would be 95 seconds in total. Now finally, at the distance from the city. This part is a bit complicated, however we can manage with it. So to find the distance from the epicenter of the earthquake from the city, we must use this little graph over here. So let's take another piece of paper. And let's mark the lag time. So the lag time for us is 95 seconds. This is in minutes. Which is 60 seconds. We have to convert our 95 seconds into minutes. So let's quickly do that right over here. So that would be about 1.55 seconds, minutes. So let's try to find, let's mark that 1.55 seconds over here. So let's start off at the edge. So this right over here is 0. So we're gonna mark 0 over here, and we're gonna mark 1.55 seconds, which is right about there. Okay, now we're gonna, anywhere we place this little distance there's a 1.5 minute difference in the map. So this is 1.5 minutes difference. This is 1.5 minutes difference. This is 1.5 minutes difference. Anywhere we place it, it'll be a 1.5 minute difference. So let's try to find an exact match of that 1.5 difference for the P wave, between the P wave and the S wave. So I believe we have found it. So now we can see that has to be really accurate. Okay, so now let me just, this isn't quite accurate really, but we'll have to deal with it. Okay, so we see right over here. Alright, so that right over here is our distance from the epicenter. So that's right about 1700 miles, just about. Now, how do we plot that on a map? Well, before we do that, let's just finish up our data table. 1700 miles. Okay, so we finished our graph as well as our data table, and we know all these aspects about the earthquake. We know the initial P wave arrival time, the initial S wave arrival time, the lag time, and as well as the distance from the city. Now, we're just going to plot that right over here on our map, on my very crude map. So this is New York. We're gonna find whatever distances. So let's say this is 1700 miles. It probably isn't, but let's just say it is. So the earthquake could have originated anywhere from 1700 miles from New York City. So it could have originated here, it could have originated here, anywhere 1700 miles from the city. So it has infinite number of starting points, and that is how we find the distance, the epicenter of an earthquake.